Okay, so thank you. And thanks for all sitting in the back because it's good for my neck. I just mentioned this getting old. You know, this will hurt me now for probably 1 week, but it's okay. So let's start. Okay, I would like to talk with you here about how we're going to build an AI platform with still keeping our hard-learned principles around platform engineering, because that's very important to remember. Workload change, but let's reuse stuff we learned and bring it to this new world, because now AI is everywhere. But before I show you something, I'm here since a couple of days and I stumbled over this. And I swear, I don't know, should I buy something for my wife? Is this something, I don't know what is it, so probably somebody has to explain me what is this Obelix-style cauldron made of chocolate. Okay, so I don't know what is it, so that's why. You can eat every part of it? Okay, okay. And you buy it like this, you know, if you just you go to friend, hey, yes, okay. So, looking forward for this one. Okay, but that's not the thing. So let's recap quickly some points. Platform engineering. I'm not going to talk too much about platform engineering because guess what? It was really talked to the brim the last couple of years when it was the hottest, I don't say swear word, the hottest thing last year. So, okay, so but quickly show a recap. So this is the thing you encountered before. You had some kind of platform engineering going on. You know, people worked in their silos, committed in different things. You may had pipelines and so on. So that's one pain point. And then you get another pain point here. If you look at the CNCF landscape, and I keep up pulling this stuff, and I wonder why do I not get an ambassador for CNCF, because they probably think I make always jokes about them, but yeah, if you look at this map, you're like, what can I choose? You have to learn this stuff, so very tricky. Oops. And then it doesn't stop like this. You can think about different teams have different requirements. Some use Kubernetes, some use serverless stuff, and so on and so on. So things multiply. And at the end, when we worked here as platform engineers, we said, okay, let's build something. Let's build services we expose at our customers, our internal customers, or customers in general. It could also be non-technical people inside the company. They consume the service, and we create them the best of breed platform they're going to use with CI and everything built in. Nothing new, and should hopefully now establish in some way or another in every company who's around this. Okay, so yeah. Platform engineering, short code, yeah, a practice of building and operating a common platform as a product, so the whole infrastructure as product, as a product thinking, joined the companies and the teams started to continue this way. And of course, there's always benefits. Sorry for that small, I always forget that it gets displayed on the screen. So there's also benefits, so reducing toil, improving engineering productivity, that's very important, providing consistency and confidence, and of course, help scale teams. Okay, so again, me, Engin Diri, I'm working as a senior solutions architect in the open source area. So I'm working mainly with customers who are not customers, and we try to help them to maybe one day also show them additional functionalities from Pulumi, but here mainly working with them who are using our open source software. And yeah, I have also social, so feel free to connect with me if you have any questions. Okay, so working in AI. That's the new reality we are in now. So from Google, from ChatGPTing our name in GPT was to whatever, and always laughing about because it came up with some stupid stuff, to nowadays we can really say, okay, 1 hour here feels like 7 years on Earth. Yeah, you look like, hey, there's a framework. You look back, you look, and it's another one. You know, there's always fast involvement. I think this is currently, for me at least, the fastest I ever experienced with stuff getting released and getting done, and things eating each other. Cloud skills is better than MC. All the things coming up. And then we got also this cycle here of models, because if I had to talk 3 weeks ago, I would swear Gemini 3 is the hottest stuff. So I would really put my money on it, and then comes Opus 4.5, you know. And I'm like, wow, that's really nice, and installed some skills and then triggering the stuff. And I was really, really impressed around this one. So yeah, I'm now Team Cloud. And this is something off the track. I really say, don't stick. Brand loyalty in the AI space doesn't work. You know, take the tool which is actually give you the most benefit. Don't stick to some kind of I'm a grok guy or whatever, because doesn't matter. Things evolve very quick. Okay, story time. And this is the part that like, oh no, man, no, he comes with a story at 10 a.m. in the morning, and you know, he tries to create a law. I try to do this very quick and bundle the way to the thing I want to present you here in our customer conversation. So everything starts as usual here, coming with Slack. So a simple idea, people have to say, okay, is it readable? Okay. So we should have a way, a service in our existing IDP to let people use models. So things evolve, customer detects also, a lot of customers now also are in the AI space and wants to try out things internally. So in this case, there is the idea from the platform team to say, hey, should we extend our existing thing, pinging the manager, and manager is like, yeah, that's a great idea, go ahead and extend our existing IDP. So now you created this, and go ahead and announce this internally inside your customer. Like, hey, we have a new service available. Now you can deploy AI models and you can use them. So of course, people go crazy. You get the millions of like buttons in your post, and they try this. So now comes the point of things evolved, the word spreads inside the company. Hey, we can now do GPU stuff. We can now provision our own models. People really like this. A lot of people want to try this. A lot of regulated areas wait for this kind because they're maybe not allowed to use some frontier models from the web. So they really like this idea. But then hits this kind of message like, hey, I can't provision anything. Looks like there's no GPUs available. What's going on? And so on. The deployment stuck and pending. So what's the reason? Yeah. The implementation, the first implementation is like, okay, everybody gets a model, and then we see not everybody has unlimited resources in the GPU area, so we used from our services, we are allowed to have in our Kubernetes cluster, for example, all the nodes who have GPU available. But what we can also see then, if we make the investigation, that a lot of GPUs which get allocated for a model are underutilized because people just provision this, we make some kind of resource hoarding going on, they moved on, they didn't work, and they may be allocated but are completely underutilized. Because that was a traditional approach. The first one you do naturally was like, okay, Michael comes, he's going to provision a model, then Jessica comes, James, and so on and so on. So you get the idea. Everybody got his model deployed on a node, and then we can see, yes, losing the GPUs and the resource hoarding, all this stuff. We come back again into the situation because I'm from Germany. We have in German a phrase called "Haben ist besser als brauchen," means to have it is better than to need it. So we always order this stuff and never release it or return it, and then sometimes we forgot about it. The only persons who really appreciate this kind of move is, of course, NVIDIA, because they're going to sell you some nice GPUs and some new servers and so on, or maybe you order them via AWS. Okay. So this screams definitely for a solution. At the end, we are engineers, we are here to solve problems, and now we have a real problem here. The quick and easy way doesn't work. So, whoop. Okay, so that's me. With our customers, you see, I'm not really fitting well because sometimes, and most often, the customers are much, much, much smarter than I am. So let's see how we come up with some ideas. And this is typical brainstorming here. We said, okay, let's increase auto-scaling of nodes, or set quotas in the cluster to prevent the GPU overuse, or comes the thing here, use, for example, multi-instance GPUs, the time slice, so having the NVIDIA operator started, and then let people use slices. Okay, and of course we discarded the ideas again because auto-scaling with the nodes, there's still a lot of people in the company who are going to use this. So you hit again, but just delayed, you hit again the same problem. What could be a possible reasonable max to use here? if you take this now here, the customer having a cloud resource, but take this for on-prem, for example, you may be physically limited of what you can do because your servers has just this amount. Quotas, again, running into the same problem still if we run some kind of quota. And same goes with the slices. So not only that's something to implement here, but again, people will maybe try to get multiple slices and then we come back into the same situation. Or depending on the model size, you will discover that the slices are too small. The model doesn't respond as we would like in a timely manner. So it doesn't work. You sacrifice a lot of the UX and stuff just to save a little bit money here. Okay, so we need to move on. So what should we keep from the learnings we had? So one of the things is we need to get all the GPUs back again. We should not split them here for the people. We need to collect them all back again. What about deploying each model only once? So that's a thing to say, okay, a lot of time, let's say the GPT model, for example, is used from several people. So instead of giving several people, we should just deploy. And now comes the point, give people some kind of access to this and say, okay, you also need GPT OSS, for example, or Gwen code or whatever. Here, there's a way to get access to this. Okay. So now we come to the idea to say, okay, wait a minute. Backtracking to the whole platform engineering slides I present. So wait, this is quite similar here to infrastructure as a service. So this is something we also made before and we know this. But now let's term it here model as a service and say, hey, we created now a MaaS. So the new way, model as a service. Okay, so what are we trying to do now here in the new world? What we do now is we give access via APIs to the pre-trained models or to the models, so people don't need to run and deploy their own stuff. So that's I know it's boring, but it's some in this area was very interesting to implement this. So now how does the story continues here? So you can say now, hey, Sarah pings the platform team and say, hey, can I have I need Llama, for example, Llama 3 with 70B context deployed. And the platform engineering team, the ask comes in. This is one channel to ask for this. And the platform team is like, hey, wait a minute. We already have it. Go to our IDP and get your access for this one. And then you can work on this. Or there's something new, for example, here for GPT OSS. And then the platform team gets the feedback cycle and say, hey, that makes sense. I'm working on it, and I will let you know when we deployed then the new model, and then you can access this. So what changed? So before we had I need my own model deployed, and now we have I need API access to the shared model. Now we're coming into the shared space. And of course, because we are a platform engineering team, we can now use our existing communication channels to let people know when something new arrived, and people can then access this. So you release new, it could be part of a golden path, a part of your service catalog, that you now release the stuff, and people know about this and can start using this. Okay, so far so good, but how does it look from an architectural overview? And when I got the approval for the CERN speaking here, I was very, very afraid that my architecture will not probably look as sophisticated as the people use it here. So I'm sorry if you are used for a more sophisticated style, but we made it very, very easy. And this is the beauty of Kubernetes, that we can reuse our existing platforms. So what we did now, we created our own AI IDP on top of it. I will talk about each piece extra. And then we deployed LiteLLM on top of it, K-Serve here doing all the heavy lifting of the model serving, Carpenter, and Jupyter Hub, because there was also the need for some notebooks, Jupyter notebooks. So that was all now bundled under this new extension, new AI capability of the platform. Okay, so let's head into K-Serve. So if you did not know this, so why we choose K-Serve and what is K-Serve? So K-Serve is here a model in inference platform. I don't know, this word is really getting me every time. So we have two parts here. We have a generative part and a predictive part with the supported runtimes. And as you can see, already supporting here vLLM, which is for me a very powerful runtime. And then under the hood, we have also support here for different AI gateways if you want to use the inbuilt functionalities. It's using LLMD. I will also talk a little bit more on the detail. And most importantly, the base is Kubernetes, and then we can use some auto-scaling mechanism. There are two ways to install Kserve. You can use the standard way, where it really uses the Kubernetes-native APIs for deployment, for rollout, for scaling. But you can also deploy with Knative under the hood, and then having also some gateway function is very, very powerful. I will concentrate here only on the generative part, because we just want to use here model serving. Okay, so I just mentioned, so provides a unified interface, supports standard Knative pod autoscaler and all the stuff. And if you want, but we will talk about this, we can really scale to 0. But spoiler, it's not that easy, like it's on the slide. But you could go also to 0. But as I said, you can use different scaling mechanism. Kserve also supports some Prometheus metrics where you get a little bit more insight about the RAM usage. So you not only see that there's maybe something going on, there is one session going on, you can also see the usage of it, and depends on this to run, scale up, scale down, because guess what, some prompts could be more difficult and more demanding for the system, but at the end you just see, hey, there's one thing going on, which is not enough. So Kserve delivers the stuff. Additionally, to give everybody here the secure net of the CNCF, Kserve was accepted in September 2025 as an incubating project, which is also very, very cool, because again, if we're going to select, you saw the slides at the beginning with the huge landscape and so on, I always like to have first a look on all the CNCF projects to then decide how I'm going to continue. Okay. So under the hood, it's also using vLLM as a runtime, but also LLMD for here, making some nice distribution of LLM inferences. So it has some capabilities, multi-accelerator support, the key value cache-aware routing. So it's a very powerful distribution for your inference. So that's already built in. Have a look on this page. Very cool. And then, of course, vLLM. So there are different runtimes, and I would say from the experience that vLLM is for me one of the most powerful ones. I don't know how your experience are. And yeah, has also here some very cool functionalities, and feel free to look up if you're interested into more details. Okay. Additionally, Kserve with version 1.0.16 also supports now here different type of workload definitions. So they created a new CRD called LLM inference service, where you now can define, do I want to run the things on a single node? And this is the most interesting part, because it uses LeaderWorkerSet under the hood. Before, we had LeaderWorkerSet as a separate thing, didn't use Kserve, because we really wanted to have here a multi-node approach, where I have a leader taking care of the worker nodes and split them on different GPUs on different nodes, which is very, very powerful for large models. So this is already built in, but you can also go for models which have a shorter context window to say, okay, to go for small language models, you can say, hey, let's go for a single node approach, but then having multiple GPUs. So very powerful on this one. Okay, so as I mentioned, there's also a problem. So I don't know if this picture is appropriate, but yeah, there's also a problem we quickly encountered when we worked with this, and this was the cold start problem. Okay, everything set up is fine, neatly done, but when you start to deploy, and I mentioned I use Carpenter, we are on AWS, so it's going to detect the need for this specific node type you define, and then gets it and provision it on the start. So the problem with the first approach, again, yeah, simple manner. You saw the Sesame Street bird at the beginning. That's me, so making the very simple approach and YOLO through and say, hey, let's do like the documentation say this. But this was the problem with Carpenter, that every time a new node gets provisioned, it went to Hugging Face to download here the models and store them. And then you can think about here, large models have multiple gigabyte. We're talking in the gigabyte area, which takes a lot of time. Think about latency, and then you can see why people had to wait a long time and why you run into this cold start problem here. But then again, if you dig a little bit in the documentation of Kserve, you quickly find out they have a cool way also to solve this kind of problems. Yes, there are ways that you could store the stuff in your S3 storage, for example, but we could use OCI images. That's very, very cool. So we package the model weight as an OCI container, then the model data mounted directly into the container. We don't have any external calls anymore to Hugging Face, for example, or to an S3 at a startup. And again, we leverage the existing infrastructure we have with containers. You maybe have the ECR, maybe you have Artifactory already running and so on. So you can reuse this because the OCI way proves to be very cool. So what results here in the benefits, we had really blazing fast startup times, because now everything is already as a container, low disk space usage, and performance. So that's really, really cool. And it's, as I said, completely compatible with Kserve, and you just needed to change a little property in your LLM inference service, and it quickly picked it up from OCI. And how we created this, so that's an architecture diagram where we can see now the people from AWS created here the bottle rocket image cache tool, which is very cool. So you just execute this, you say, okay, I want to use following model. What this does in the background, it's going to boot up an EC2 instance with the bottle rocket AMI, then downloads the stuff, creates the volume with the downloaded stuff, and then automatically take a snapshot. So if you go to the EC2 instance view, you will see under snapshot, you see it creates a snapshot. It's not the quickest thing, it takes some time, because depending on the size and the thing, but you run it once, it creates a snapshot, and what you can do now, you take the snapshot ID and bring it back to your Carpenter definition of your EC2 node pool. That was also one of the things when we wanted to use this functionality. We started with AWS Auto Mode, because hey, AWS Auto Mode has Carpenter already built in. The problem is AWS Auto Mode doesn't allow you the full functionality of Carpenter. So what we had to do is then go back to vanilla EKS and install Carpenter on top of it via the Helm charts on our own. So we have some kind of hybrid going on now. But having still the scalability from Carpenter, choosing the right nodes for us. But here comes the twist, using now our snapshot we created with the pre-baked containers already in, proved to be very, very cool, because now you have this blazing fast speed. Another thing, Hila, she's a solution architect at AWS. She highly recommended me to check for our next iteration here, Run AI Model Streamer. That looks like a very interesting project. I have to dig into this. What it's doing here in the background, it's going to load directly to the RAM of the GPU, the weights, which is really cool. So you really cut completely the storage part and say, okay, let's take this and go straight in the memory to have even more blazing fast load up times. So I have to check this, how does it work, and you will probably see next year a lot of talks around this, how to make the stuff blazing fast and quicker. Okay, LiteLLM as an AI gateway looks like this. I will show the demo. We have now the proxy functionality, we have authentication, we have routing, tracking, guardrails set up, chargeback, which is very important, because now we would like to track also the usage of the people of the LLM we are providing, because guess what? They're costing money. It's not cheap on AWS to run this stuff. And here, it is compatible to OpenAI API specification, so it's just a drop-in for the people to use. So that's the thing we chose LiteLLM. I'm not 100% sure if currently are better AI proxies or AI gateways out there. A lot of work was done. I said a couple of things. A lot of networking companies create now their own gateways. So, and you saw K-Serve has also inbuilt here with Envoy, so that could be something to re-evaluate, but it worked in this case. Because as I mentioned, we can now define the token costs for our self-hosted models and say, okay, this is what 1 million token will going to cost you, and charge this back to the team. So we have again here the observability, everything, and the visibility as we would like to have when we provide a service for the customers when they spin up a Kubernetes cluster or whatever. So again, here it's back. Okay, how does the AI IDP look like? And this is just an example because I cannot print out the full stuff they have already in place. So I took out some of the pieces. So we have our available models with the informations you have in place. You can look, okay, what is there? We will see this in action. Most importantly, IDP, we are now completely self-service. We can go, we can create now an API key for the models and hit over to the subscription to see this API key, where it's used, and most importantly, we have also the FinOps part where we can see the usage of this API key. Okay, let's head over to a not overly long demo, but to give you a little information. So let me show, how do I choose not mirroring display settings, okay. Sorry. So, okay. So, okay. So first of all, let's get, I hope the internet is okay-ish, because it was a little bit wonky this morning. Okay, here it is. So let's have a look at the model as a service, and I can't, for the sake, not remember the IP load balancers. So this is how the user, the developers will see the IDP enhanced platforms. You see the models. You can click on this. You get informations. You get even code snippets they can use to quickly pull the stuff. You can go to your API keys. You can create a new API key. You can see some additional information. You see the current spend on this one. Get additional graphs, which is very important. You never get enough of graphs to show the usage, and then you can also recreate the token. That's one part. In your subscription, you see the key to which models it is subscribed. This is very important, and can then also see the drilled down informations around the spend and all the stuff. And of course, you have here the overall FinOps view where you see, okay, which model I used, which key created which cost. That makes very clear for the users, and us as platform engineers, we can now really charge this back to the teams and give people at the end of the month also a very detailed view about this one. Okay, so that's one part, and then let's, the LiteLLM is another one, and if we go to our notebook, we can also spin up now our notebook. How many minutes we still have? Okay. So I will fasten this a little bit up. And then we see also, yeah, the notebook gets spin up, and we see in our, where is it? Here, we see the notebook is also started. I could choose at the beginning, which was very interesting for the people, if I want to run it on CPU, if I want to run it on GPU, because my system allows this stuff. Okay, and last but not least, a little bit of code, because without code it's not possible. So how does it look under the hood? Let me show you a little bit. So here creating, of course, the whole, let me make this a little bit bigger. So creating the EKS with all the add-ons, everything needed. That's one thing. Storage driver, but most importantly, we see here now the Carpenter installation, also quite clear, using pod identity, that's very important. But here we see now the GPU node class we create, it's the EC2 node class inside Carpenter, and the most important part is here now the snapshot ID. That's how you can look up and say, please use the snapshot with the pre-baked stuff. So that's one thing. For the general stuff, it could still use a normal, the generic bottle rocket image, which is completely fine. Then defining here a dedicated Carpenter node pool rule. So in this case, for the GPUs, you can say, hey, this is the allowed instances, or we allow everything in the G area, whatever. And then you can set up some tainting and say every workload which is needs for GPUs allowed to schedule this. So you can see it's really using all the stuff we already learned, and then you can say, okay, how to consolidate this. So this is quite aggressive with 1 minute. You could say, okay, because of the cold start problems, it's not 100% solved. Let's make it maybe 1 hour, and then we are on the same side that the pool are sticked for 1 hour, and then the start time will increase. So that's one part of this one here. Is there something to mention also? Here's the baking process. So for the models. So what I use here is where is it? Code build on AWS. So creating a code build run. Because guess what, having this run on your local Docker engine or something on your systems could also affect a little bit the performance, because you have to download it and upload. I want really to not get bother with this. I could also thought about Docker build, but because we are in the AWS ecosystem, it's not a pitch, you can use other systems too. Code build was very nice, and then just upload it to the ECR and make it available. Okay, so with this said, let's head back to the slide. Well, no, that's not. Let's do it like this. Okay, so as a result, we had before several deployments, here 10 deployments. We reduced the deployment now really to 1 for this specific model. We reduced the amount of GPUs needed. We can reduce the costs, obviously. We then maximize our GPU utilization. Oh, that's a broken slide. And so now the impact of this: faster time to production, reduced costs, better governance. I thought about this, setting guardrails and audit trails and all the stuff is very reasonable also for AI workload. Of course, improved security with a single point. And we see now AI platform engineering now, it's nothing else than we had before, but it's a change of the workload. So we still do what we want to do. Enable our customers to use, to be quicker on the market, sorry, and increase the productivity. Key takeaways, yeah, let's jump over this to not take too much time. So, yeah, without platform thinking here, our GPU cost spiral, we enable the developer freedom, we create visibility and accountability, and of course, we still have here shared infrastructure is not only shared resource. With 19 seconds to end, I say now Q&A.
Excellent. Thank you very much. Let's thank Engin again.
Thank you.
So we have time for 1 or 2 questions. Yep, there's one there. Just wait for the mic so that the recording also gets it.
Yeah, thanks. So I have one question. Yes. You were talking quite a lot about optimizing the GPU usage and then scheduling and all these things. Do you offer to your customers, users, an option to get workload scheduled based on the number of loaded layers? So there are models that are tolerating like loading only half to GPU and then half to system RAM, like for example Mistral models. If there would be a budget-conscious user who would say, I'm fine with half the layers in GPU. Is there an option for that in your system?
Currently not. As I said, things starting, we work here together with our customers, so that's the thing we are now evaluating to say, how does the story continues with the people? Are they accepting? Because we still have the fear of platform engineering that people are not taking this because they fear something. And yeah, it's something to evaluate. But you see, it comes all down to the pain points, because the solution looks maybe easy, whatever, but you see under the hood there are much optimization potential for this kind. And now comes also the point, I'm not originated from the ML area and so on, so for me this is also very new. I had to learn a lot of stuff around this area. So while we are going, we're learning, and you saw the one with the model streamer, for example. We are now currently solving the problems of the cold start. Say, okay, we don't want then people order something and nothing runs because we want to scale to 0. How we can increase this time. So the baking thing, that took quite a time to wrap the head around this kind of stuff. But yeah, that sounds also some interesting part to think about.
Okay, thank you.
Thank you for the input.
Excellent.
That's
and we are out of time, so let's thank again. But
Yeah.
before...